Okay, we're just at the test chamber at Enerblue in Alessio, our lead commissioning test engineer. This is a 120.4 Palladium unit, ultra low noise, 74 dBA sound power level. But the important thing we're going to show you, we get a lot of questions about defrost. So this machine now has just started its defrost cycle. Defrost cycle is going to last around 4 minutes. This machine has basically phase defrost, 2 circuits. One circuit goes into defrost, second circuit comes in to compensate and to neutralise the output temperature without too much temperature degradation. Interesting thing is the amount of moisture we're going to see coming out of the unit as the unit starts to defrost in anger, which will be significant. So a few things to look at. Top of the unit there, a lot of mist coming off the unit. We're starting to shed ice now, and soon we'll start seeing liquid flowing out of the unit. This is a twin circuit machine with 2 compressors on each circuit. Capacity at -5, the ambient we're in now, 85 kilowatts. Capable at that temperature around 65 degrees. This machine's going into central London on a project calling for extremely low noise levels. So this machine will be commissioned during July, and we will be able to provide more details on the application once it's in installed in this corporate application. The machine's gone into reverse cycle now, and we're starting to see the ice come away from the unit. If we keep an eye on the pipe down here too, just in front of Alessio, we'll soon see quite a large amount of moisture leaving the machine as the machine runs through its cycle. As we said, the defrost cycle will last around about 4 minutes in and out, leaving us with a machine ready to go back into action, with the second circuit here then going to go into defrost to follow. This machine operates on Skoll compressors. It's a propane heat pump, so an R290 natural refrigerant. So all the assets and the specification we need moving into a high specification input sector. And there's our moisture literally falling off the unit. We start now seeing moisture flowing out the coil, which will start to become significant. Moisture content removal, obviously a factor of defrost cycle time, ambient temperature, and relative humidity. As you can see, the amount of water coming off an air source heat pump in a defrost situation is not to be underestimated. So obvious discussion regarding drainage and removal of this water. So there we're looking at one circuit around about 45 kilowatts capacity running through its cycle. On this unit, all the condensate's taken back to one point, so it's relatively straightforward. Really nice to remove that condensate in a straightforward manner. That's where we'll start to drop now, and we'll look back on the coil, and we're now seeing all our ice disappear, and the unit ready to go back into action. As we said, the defrost on the second circuit will follow in due course. Okay, there we have it. There's a high specification heat pump going through a defrost cycle, and gives you a great idea of the amount of volume and liquid that these units will remove. Okay, look out for more of our videos.